I'm really pleased to be here. I come from a different background, as Titia suggested. I actually am not a computer scientist, I'm a mathematician. So my main objective in life is to identify problems and solve them. That's what mathematicians do. And then make other people actually do the solution part. So what I will be sharing with you today, and I do have an agenda here, I will be sharing with you some of the research that we have done as part of Microsoft Research Computer Science initiatives. But from the perspective of the scientific record, I'd like to just ingest one thought that the approach that we discussed today during this presentation and later, keep in mind that digital is very, very different from what we had. And I know we all know that, but we don't quite know how, because the computing technology has done an excellent job to make an impression that we are dealing with something very similar to what we had in the physical world. Just look at the books, you get now little tablets that look like a book, and you can do many more things. So the whole industry, the whole design has been working towards us ignoring this very different. But when we have to come to the essence of it and think about how we can really keep it for a long time, then we have to become aware again that it's not physical, it's all electronics. It's almost like a rainbow. You see it only while the computer is running. And you see it only while there is electricity so you can run it. And that's what makes it so esoteric on one side and deeper experimental on the other side. And so the question really here today is, how do we preserve a rainbow? And I will try to illustrate really how that reflects in the designs and technologies. But I will start first with the discussion of scientific work, because we approach the objective of a scientific record as understanding what is happening before we can come in with technology to help the objective of improving scientific work. And the strategy really was, how do we understand the data, the tools, and resources so that we can, in the future, reuse the scientific work and progress it further. So that was the perspective. That probably is the overlap with the job of archiving, of keeping the record together. Because we are technologists, we really try hard to learn first from people who are doing this from the sociology point of view. And so we try to understand a bit deeper what the process is of scientific discovery. And then we learn, in fact, there is technology, of course, but it is essentially scientific is about social enterprise. It is something that's important to keep in mind, because we need to decide who's going to say whether what we've done is good. And in the end, we realize, well, it is a society that will decide. And often what happens is it's time that will decide. So it is a process. It's not something that I have an authority and I'm going to say, no, this is right, this is wrong. And so just to keep it in mind that we have to have this flexibility, that it is ongoing and is being shaped. And it is really emerging from the community practices. And I really put here the references so you can go back and check. Almost every statement I'm making here, it is referring to some paper somewhere. So if you think I'm misinterpreting it, please, you should definitely read this. Another thing is about sharing, representation and sharing. So how does the gathering and propagation of scientific information happens? We basically realize that it is a really complex, multi-stage process, and for many people it's a journey, because scientific really is about unknown. It is about getting to new territories. And so in a way we need to be able to understand how things move from very, very raw data, completely unknown, to something that we individually or collectively make sense. One interesting aspect was about how do people come together. And we learned about this distributed way of doing science. They're often referred as collaboratories. So something to think about, because if we know it's a scientific, it is a social enterprise, and we know this is a very, very complex process, how does this in the end gel together? And these collaborators actually emerge because of the change in technology and the ability to communicate and share. There's very good work by Olson who actually looked at 10 of these and explained how this is a very complex, organizationally very complex endeavor. And then comes to the final aspect. Whoever has kids would know that. When do we learn how to share? Well, we put 2 years next to each other, 2 years old next to each other, and they play next to each other. They won't really collaborate. Then the question is, when do we in life learn to play with each other? And it's very interesting because lots of studies have shown that the sharing in scientific work happens depending on the culture, where you are and how the work actually happens. It's very interesting work, again, by Vertesi and Durish, basically claiming that the sharing of resources or results of the work depends very much on what the environment is like. If I'm working in an environment where each individual has to enable himself or herself to do the work, they'll think they own it because they work very, very hard to actually enable this work. And then they have environments where the resources are shared. Then, of course, sharing comes much more naturally. And then there are lots of other human aspects. So the point here is there is technology and then there are practices. There are objectives for us to promote the science as a societal endeavor, but at the same time, we're working with individuals. That's from the sociology point of view. And the question really is for us who work with technologies to understand in this whole ecosystem what is the interplay between technologies, the practices, and the artifacts that are being created. So we are just hoping that from this bigger understanding we can then identify, well, problems and then solutions, and essentially decide what we're going to go after. So the approach we have taken, instead of thinking about a metaphor of a record, we said, okay, well, how about thinking about ecology? So that's the shift in mindset. So I'm not really dealing with something that's very, very static. In fact, what I'm dealing with is something that is very complex, it's dynamic, and the ecology is my starting point. The question then is, what aspects of this ecology are relevant or even transferable? Just like, as I said, with the digital, often it feels, yes, I'm trying to capture the rainbow. Here I have a ecology in which something unfolds, and so what part or what representation of that ecology can I have and preserve for later? I should also say that one of the principles of our team, when we work on some problems, we never talk about things that we haven't tried to build. Okay, so everything I'll share with you today, we have at least tried one prototype to explore whether there is some kind of technology aspects that can come in, keeping in mind that it is technology and practices that really will solve the problem. Okay, so in the first part, I will tell you the story about a user study that we have conducted in a nanotechnology center at the University of Cambridge. And the reason I'm showing you this is because I want to explain what ecology looked like for that particular environment. Then I'm going to show you a little intervention that we have done using a prototype, okay? So that you can see what sort of aspects we went after. It may be useful in thinking about the archiving part of it. So we have not looked at archiving, but we have investigated certain aspects of the ecology. A couple of pictures here about just to understand what's happening. And nanotechnology is a field which evolved primarily because of the digital. And the reason is because we humans cannot really see nanoparticles. It's impossible. So these are the scientists that are working by translating signals or data that's coming from laser beams into some graphs, and then after that, looking at materials to see whether conceptually what they've done actually happened. And so it is completely technology mediated. This is one science that really demonstrates how the digital has enabled a new way of working. And so what do they do? They do technology processes to align up particles, and then because of the alignment of particles, the material that results will reflect light differently. And this is one such material. If you look at it, put it in your hands, it may look greenish yellow. If you stretch it, suddenly it becomes purple, with no pigments in it, just because of the reflection of light. And the only way these researchers can actually investigate is by laser beam refractions from the particles, and then looking at a number of graphs and saying, aha, yeah, now I understand what's happening. Yes, they could do, nobody else, because they developed this practice of interaction with the instrument. Yeah. So what do? the first thing they decided, because it's all digital, let's then think how we can make our processes digital. The first obstacle for them was the traditional lab book. The traditional lab book is a paper thing, and when you have to have really fast movement of data, insights, transformation of data into information, you can't deal with a physical artifact that is basically non-integrated with anything else. So they decided that they will repurpose off-the-shelf software for note-taking. And that software then became for them an essential piece because it went beyond the lab book. The lab book used to be something that you outline your experiments almost often in advance, and then you record what you've done. However, as the professor who is teaching the students in this particular laboratory said, I want my students to be inspired. I want them to do things that are unpredictable. This is the only way I can ensure that I can have a jump, I can leap. And so the traditional lab book and the practice around that time, he felt, were actually not compatible with what he wanted to achieve. So here it is. The lab book of that is used for a number of aspects. First of all, the practice that they evolved around the digital involved ingest from the information that they in a lab into a lab book that is very diverse now, multimedia document. And then they will go to a process of what we call analysis and synthesis, and finally interpretation and validation. So I'm just showing you very simplified a workflow that would be applied to almost any project that they've done. And that's sort of just for the first stage. Imagine yourself, you're in a laboratory, you just align your lasers, and then the data is going to flow onto the computer in the lab. And then suddenly you get these images, and you wrote a program that can fill up the form. So in a way, you have streamlined as much as you could the transfer from sensor data into something that computers can further take. And then they apply a number of analytics tools. But then as a student on Friday, you're preparing things that on Monday you have to show to your professor. So what do you do then? You have done about 150 experiments. While you were doing them, you found a couple of things that are very interesting. Now, you're not going to come to the professor with 150 experiments. You're going to take a couple of things and put them in yet another artifact. And in this case, the artifact is slide. Okay, so they move from one node laboratory to one slide. And this now one slide becomes a nugget of information and a bud of new knowledge that will then evolve. And so what do they do then? So here is the group meeting. All around this one slide, thinking about something interesting. The professor says then, well, you know what? This one looks all right, but this one doesn't. Can you go back to the original data? Okay, now look at the panic. You can imagine panic. Now I have to go back to my 150 experiments and dig this one out. So this a linking and necessity to revalidate any statement that you make based on the data back is very interesting. It's happening right here during that process. So after the discussion, and this is often very kind of group discussion, in which people are challenging, thinking, dreaming up, imagining the vision, thinking, oh, that would be a fantastic paper if I can do. So there's this great enthusiasm and energy happening right at that point. They will come up with the action plan. And where does that go? Well, in the same lab book, but a lab book of a different sort. It's not a lab book for an individual. It's a lab book for a team, which would then be enrolled into a lab book for a team for a project. So then what we've got now is similar technology with different types of role in this process. Okay, so here I'm just kind of summarizing how that went, from raw data to gathering and then to action plan. And that goes from 1 week to another week. So you have iterations of it, and data is that's being accumulated and so on. Yeah. So what is this now? We realized we have really interweaved digital artifacts. There's not one thing that one can pinpoint and say this is actually what led to the innovation. And the paper that comes at the end, the publication that comes at the end, doesn't include any of that. Because what we understood also, the paper writing is almost like a marketing exercise. You have 2 or 3 conferences you can go to, and now for each conference you're going to essentially reposition it to take a particular angle that's of interest to that community. And so it's very interesting, because then what we have in academic papers is just one aspect of the innovation that happened. And the full record is staying within this ecology. Okay. So we will try to kind of figure out what are the implications of this when we're looking at the whole ecology, and how can we even help these scientists through the process while the process is unfolding. So it is really true that the data is important, but the reuse of the data is absolutely the key. That's not it's not about data itself, but it's about all the intermediary artifacts that happen while the data is being considered and so on. So if somebody says, I'm going to create a repository of data and enable scientists to progress science, well, we will say it will be really a stretch and try to measure the success. I personally would not subscribe to that, because I will not be able to measure the success. Okay. And then the question is, what do we do? Because we could have snapshots of these environments. Would the snapshots of these environments do? So if I just get the whole environment and say, okay, this is the environment from University of Cambridge, here is University of College London, can you use it? Okay, so in a way, okay, let's just go the other extreme. If you do this, what would be necessary to kind of do the bridging? We're here providing at least the guidance and saying the environment has to stay rich. We need to see which of these links between technology practices are intrinsic and need to be preserved in some way. Now, we asked the researchers then, what can we do to help them within this particular ecology that evolved, and the processes are there, working, obviously, because they're successful, but in many instances suboptimal. And I will be showing you something because I heard a lot of discussion about the role of archivists and librarians, about curation. How do we make sense, and how do we create a record that's meaningful for everybody else? And that comes from this other comment before. The society is a societal endeavor, yet archivists have this really difficult role, giving it a shape. So that we have to shape it, and then somebody else can consume it. And so I'm just showing you now a tool that we gave scientists to shape it. So we said, okay, here is your project. What would you like to do? If you have to go on that Monday morning instead of with one slide, you go to a professor and say, yes, here's my slide, but look, I've done all this so far. How would that look like? So the first question, we asked them what would be their desires. And it was very interesting, because even though the laboratory is all digital, and the claim is that they are going all digital, and in the professor's office we found this desk with all these papers printed. And we asked, so cheekily, we asked what was the meaning and what is the purpose. And the professor said, this is an overview. Yeah, this is an overview. I know what we are working on. And it's in front of me. It's my office. So every time I walk in, I can actually see this is what we have done. So we said, okay, well, could we then provide an overview? Maybe this is what they need. They need an overview. And the second thing is, the professor said, and look, they're all stacked up. I really would like to be able to just auto-sort them. I just press the button on my desk, and then all these papers now suddenly rejiggle themselves and put them in different order, and saying, yeah, and this is what Mark is doing. So it's not stacked based on the project, it's based on who's doing it. Or, no, this is done on this type of material. So now, quickly, repositioning based on the material. It was very, very useful for us, because then we decided, well, we've got designers here. These are people who can articulate what they want, and let's involve them. And then they had another idea. They said, we learned that there is this thing called tabletop computer. Why don't we put it on a tabletop? And we had tables anyway, so let's experiment. So the experimentation in the end was, here goes a new tabletop computer, that's good, and then it's all digital. We should be able to reshuffle. Digital is excellent in reshuffling, as long as you know how to write down an algorithm. So we engaged them. We said, okay, let's have a co-design, and tell us how you imagine the structure of your projects. So it was very interesting because we do the traditional things that you would do with your user groups and so on. And I want to just show you the visualizations of the structures that came out. So all these structures had a kind of tentacles. They're showing the paths to the discovery. And each of these branches here represent one line of thought during the process. And you can imagine on each of these tentacles, there are things hanging off, and those are different artifacts. And the flows are probably driven very much by the practice and technology, because they were using certain tools. Yeah. So it was really a wonderful experience working with them and then articulating how this ecology, in fact, in their mind is reflected into these maps, project maps, in a way. But they don't have a representation. Nobody had that representation. So we didn't get, this is still a kind of a process of understanding what it is. And in order to understand the process a little bit more, we realized that we need a bit more tools for them to express what they want. So what I'm showing you now, it's not the final solution. It was a tool for us to investigate how these tentacles and these things would look if they actually had these digital objects. So this was the idea. We said, bring your papers or bring your files that contain this content, your OneNote books and lab books and slides and posters, whatever you want to do to tell the story. And then we will enable you on this tabletop to create a map. And then we were thinking what sort of facilities we should put in so that people can work with it. And so we thought if they bring the files, they need to kind of import them. If they want to link them, we need to give them links that they would see on the surface. Of course, when they click on something, they may need to go to another link. So they may need to actually dive in and get more. Yeah. So we're thinking, okay, there should be a couple of linking mechanisms, and there should be a number of different import mechanisms. And after that, it's going to be reshuffling. So we just went for very minimal facilities that should facilitate what they said they would like to do. Here it goes. This I'm just showing you the setup. We ran an experiment. We first brought 3 students. So each student had their own project, and they did their map. Then we asked the students to come together and try to fuse the map into one, just in case professor asks, well, guys, are you talking to each other? Do you know what each of you is doing? Or I want to know what my lab is doing. So in a way, they give an overview to 3 projects. And then after that, we give it to professor to make sense of it. Hey, that's very interesting part. So what happened in the end, here is one map that was created. The students came in. The design was based on sort of a grid. So you can put things into a little box, but you can put a number of things in the box. You can dive deeper in the box. So each box on the screen can have the whole slide deck, put in little images. And then you can delete if you don't like some of them, and then you can link them. Very simple. So in the end, what we realized that there are different organizations. People come and present their work depending on what they want to communicate. And this particular person was communicating who he was collaborating with. So here's the scientific work. These are the things that I've done with people externally. These are things in progress, and so on. I'm picking this particular map. This is one of the 3, because it's very, very interesting and illustrates one point that I want to make as part of the curation process. This student has used the spatial organization to demonstrate what has been done and then show the links indicating the path of what he's going to do further. So things that have been done, some hypotheses, and what he's going to do. So he's really gone in to describe the process. But most interesting for us from the scientific point of view, from the technical point of view, was how he created it. So the student took 2 big posters, so repurposed what he was doing for some other event, and a couple of slide decks. And guess what? Took parts of it and put on a map. Okay? So what was surprising to us, we thought that originally they would bring the documents and put them there and say, okay, this document, this document, that. But to tell the story, even the document was too coarse. It was the document was too already packaged into some message that didn't really fit what the purpose of this. So essentially the lesson for us was just creating a tool that enables people to reorganize their documents is not going to work to tell the story. And of course then what we learned is the technology has to enable reformatting, because originally they brought the slide deck, but to put it in the map, they had to turn each slide into JPEG. Because in that particular environment, the only way you can do multi-touch things and so on was with JPEG. So already they had to change the artifact, the original artifact, into something else that they can put in the map. Second, in some instances, whatever they extracted could stand on its own. So this was a particular material they want, and another instance was just a pointer to a document. And then we have these links. So we had three different types of purposes that we have for something that is embedded in the map. The question then is, how do we, just think what you have now on the desktop. On the desktop you have files, and then you can perhaps create a hyperlink. We need a much richer referencing, much richer interlinking capabilities. Yeah. So for us, that also meant completely expanding the information architecture in a new ways, which is not supported on any desktop or any machine yet, because you have only a file system, and if you need to do any linking online, can't help you because you can have only bookmarks. That's all you have, and they're sitting in the browser. So organization that things online, we don't have any support. Organization things on the desktop is your file system. They're not connected, they're not rich, so there's lots of work to be done here. And we were just explaining here why this is necessary. If you want a curation platform, this is what you should go to IT industry in demand. Okay, this is a message. Okay, and just now this is the final stretch, and my main message here is about this, the nature of the digital. Okay, so this is what will make your life so much different from curating the physical, and I'm not sure whether you can devise a solution without acknowledging the nature of digital, because your strategy may depend very much on the constraints that are imposed by just holding onto this digital. Okay, so first thing to explain that the file itself, from the computer science point of view, I had to learn this. As I said, I'm a mathematician. I had to learn that there is something you have a program. There's something called input and something called output. Okay. Now, when the first computers were done, when Turing was the first one to conceptualize it with his colleagues, engineers, they didn't have screens. In fact, what they had, there was these pipes of machines, and then they would type in things through tapes and stuff, and then outside would come output that would be printout. Okay, that was it. You have a program in. Every time you want to do something, you actually have to type it, put it in, and then you will get out the output. And then mathematicians, statisticians, engineers will say, aha, yes, this is fantastic, we got these results. We didn't have to do it by hand. That was the main purpose of computing. It was about computation that we humans could not do in our heads or on the paper. And so it was, from that we have moved very far. Now, what we have now is what's called stored program. So we don't have to retype the programs. We can just keep them stored. And also, if the program is enabling you to create something, like my Word document, I don't have to retype it again every time, because I can say what I've done. But every time I want to see what's in my file, I have to pass it through the program. Okay, so my file is an input to the program. That's what it is. And if you want to save the file and you don't have a program, you cannot get very far. That's intrinsically the nature of it, intrinsically. And it's not fully appreciated. And the reason why it's not is because we have designed all the applications not to think about program. IT industry doesn't want you to think about programs. If you look at your file desktop, they will show you this is your C drive, and this is a program, and don't touch it. Also, often it's grayed out. You can't even go there. Okay. Well, what I'm saying is there is a reason to this, because not everybody can deal with this program without messing it up, and you have a huge support cost then. But just keep this in mind. If you have a file, it's not enough. And another thing that's important to know is the reason why we love files is because the same file can be run by a number of programs. And each program will do something different. Okay? So the same file that I created, say, in Word, will be indexed by Google and Bing, and I can search over it. Perfect. I love that. Yes, but it's different way we extract value out of it. So let's just keep this in mind. So files are necessary, but they are not sufficient. In mathematics, that's a very important distinction. I need to have them, but that's not sufficient for me to actually see it. So I want to just show you a couple of slides which demonstrate that, in fact, it is possible to keep the files and programs around. And here I'm just showing you something that's now 16 years old. So on the left side, I'm showing you a virtual machine running in the cloud with Windows 2000. And then on the right-hand side is another virtual machine running XP. So I have not done anything. This is the technology that exists now. So if you have somebody with scientific record that was done 16 years ago, well, here you can put it in. And I'm just showing you, I'm not showing you a live demo because the setup will be a bit more difficult. But I'm showing you, you can see the startup menu 16 years ago that we used, and a bit later, 2003, okay, 14. So in a way, I'm showing that it's possible to have things running just as they were. There's no reason not to. If you decide to go immediately for the conversion of files into something else, you do it because you want to extract value out of it. Yes, you want to get more value out of it because you want it in a different program. But there is no reason to give up on the original. Absolutely no reason. Here is, for example, MapPoint. You remember MapPoint from 14 years ago? MapPoint, that was predecessor to Maps. They're all running just like they used to 14 years ago. It's not a problem. So in our thinking about preserving environments and this aspect of understanding that there is an ecology concept of it, there is no reason not to have it. The curation, as I said, needs to be supported. And I just showed you what demands you can make. If you wanted to make the curation more interesting, more valuable, easier for you, easier for society, and so on, we can then go that direction. We can try to find define these tools. But please, don't give up on this one. Thank you.
Even earlier.
Okay, that's a problem.
So are there any questions? Please.
So as you were describing this process, which I think is amazing, and I wish to download it, if I can somehow, the commentary or the evaluation of the research is also done in a simulated-like way, I think. So, like, for example, when you were saying rainbow-like, this is, the research is like a rainbow, and you kind of, when the electricity on, also the commentaries may be, like a rainbow-like, or the reflection on the research is also not necessarily always captured when the electricity is not on.
Yes.
So how do you come to terms with the whole spectrum of activity around research that is not being able to materialize in such a nice way?
Yes.
And how it has evolved, because I'm sure that some of it had been catered towards questions like that.
Yes.
Who's talking at that point about something that can lead to another thing,
yes,
and things like that. Thank you.
Yes, thank you very much for this question. It actually raises one important question about who are we right this moment, looking at this process and deciding what we are doing. In a way, whatever happens in real time is what happens in real time. Everything after that is rationalization and post-processing and making sense. So in a way, we are the people, and in particular archivists are the people who are trying to make sense of things for a particular societal purpose. Yeah. So, and I, as a researcher, when I stepped into this environment, I was there making sense from the technology development point of view. So it will never be an independent sort of process. We need to reflect who we are. If we are to ask even professor who is leading the lab, he will be answering the questions from his purposes. Yeah. So unfortunately, there is always a perspective on it, and we have to be crystal clear. If we are crystal clear what that perspective is, then we just support that, and we say these are the boundaries. You're also asking the question. To these are the question would be interesting to ask the professor if he were to make all the records public, and then also ask the team who would be comfortable showing what. And that goes to a much deeper question of the privacy. I would call it also self-determination, because they have a right to decide how the rest of the world will perceive them. Yeah. Thank you.
Can we have other questions? There's another question.
Hi, Natasha. It's Jim Mihalko. So I'm going to ask you to try and restate, trying to make at the end here by showing us these fixed points. I realize it wasn't a live demonstration. Perhaps put it into the context that Ricky was talking about, where we've got those stages of create, use, fix, create, fix, use. What were you urging us not to give up on?
Okay, let me make it more clear. And in fact, it just yesterday, it was a sad circumstance. I was contacted by a professor at one of the universities in UK, and who basically said, Natasha, your name was given to me by my colleague. I have terminal cancer, and I have Windows 7 machine with 4 terabytes of data, and I have this grandson who is a sort of a geek, may want to look at it at some point. That was basically this statement, and it is possible for me to put all this machine that he's got, Windows 7, onto cloud, into virtual machine, so that his computer and all this data and all the programs run just as it was on his desktop. That's possible. So whoever wants to go back into time can go in and use the applications just as they were. I will put, or whoever decides to have that preserved, would from time to time have to change the virtual machine, because that's something that's been progressing, that will be progressing. But whatever is inside will run. So you can go back. So then the problem then is not about technology, whether you can run something. The problem will be whether there will be knowledge about this, whether there will be somebody who will know how to click the right buttons. I'm showing you here a map point on the left side, which I'm familiar with. But then on the right-hand side is another application, it's Microsoft Money, which I never use in my life. So I would not know how to touch, what to do with it. The people who did use it, they will know. So I'm basically saying, don't give up on the fact that the software is not there, therefore you have to give up, you have to move your files into something else, because that something else can run now. So you may move the file that was in Microsoft Money into Excel, for example, because Excel is running now, but Microsoft Money is not, for example, just to give you an example. Because you can run the original Microsoft Money. The reason why you don't do it now is because you cannot buy it in a shop at the moment. But that doesn't mean that the companies who created them do not have them. They do have them. And there's no, at the moment, even if these companies, if they want to give it to you or provide as a service, there is nowhere to put it, because it's not their core business. So there are lots of documents in WordPerfect, for example, still. And WordPerfect company as it used to be doesn't exist anymore. You can go and try to trace who owns the license of WordPerfect 5.0. Okay, but I can show you, I mean, if I had a live demo, I can show you, you can see the WordPerfect 5.0. It's running on XP. So why, on Windows XP, so why wouldn't you have it? So that's what I'm saying, don't give up on this. You go back to IT industry and say, we want all your software. And maybe with UNESCO or somebody, we can create an organization that will be a repository of the software. So let's make an international effort so that now the human civilization will have access to the brain of the digital. You cannot have digital without it. It's alive to it. I have a dead file and I need to give it life. The life comes from the software. So let's do this. Once you have that, and you shouldn't give up on this, once you have that, then you can provide solutions on top of it, different workflow support and so on. Yeah.
I would like to add something to that and turn it into a question. And turn it into a question. I mean, you said the problem is not to bring that to life. The problem is then to know how to
Yes.
to use it.
Yes.
So when I came to the Netherlands, they took me to Franeker, where there is a museum of Isaac Einzinger, who in his lifetime in the 15th century, or 16, I'm not sure about it, maybe even earlier, decided to build a whole planetarium or a whole kind of solar system actually in his living room. Yeah? And if I recollect that, so I'm looking to my Dutch colleagues here, if I recollect that, he built that, and then it was a machine in wood, yeah? And it was kind of disassembled, and they could rebuild that, I think in the 20th century, using his documentation. Mm-hmm. So maybe documentation is an answer to your question, how to use those tools. Mm-hmm. But then documenting stuff is also extremely costly. Mm-hmm. So who should make a decision about what to document and to which detailness?
Mm-hmm. So the first issue is that nobody can see this. What I'm showing you now, you can't see. Our students in computer science don't know how the Windows 94 looked like, or 98. They don't have a clue. My kids don't know anything before internet. So first thing is to make it available, just like you had pieces there. And then we work on human intelligence, not computing intelligence. We have to develop knowledge and maintain it. There's no other way. In the end, it's all in our heads. And if it is written somewhere, it has to get into our heads to process it anyway. So, but without the first bit, we can't even have the human intelligence to reason. When it comes to software, when the software was released, there's normally lots of documentation from different perspectives. There's documentation at the program level, at which developers are operating. But I can tell you there are lots of books published about Windows for Dummies, Office for Dummies, and then you have things that are for computer scientists. So we are lucky because, at least with the digital, whenever it was released, there was enough of the market push for people to provide. But that's, again, not enough, because what we are talking, archivists, they have another job. They have to make sense even of that, because it's all about distillation of knowledge. You have to distill it further up, and further up, and further up. And that's what we humans all do. But you have a particular mission. You're doing it for the society, from a particular perspective. For you is to decide which perspective, but don't lose, basically I'm saying, don't work with this much. You can work with this much and ask for support to do the distillation. Because you are not supported. I showed you one curation tool for the students in this laboratory. You will be given what? A database screen to type in some metadata. And then you will be gathering information semi-manually, because even the search is not helping you well. So I would ask, because it's digital can be supported in many different ways. Ask for tools, ask for things that can support the job. And then engage the rest of the society to come on board.
It's quite interesting, and it's very interesting to see that you're actually, being engaged in trying to ensure that your programs can run, which ran for, centuries ago. But I think there's one thing which we need also to consider, and now this is about the scholarly record. The investigation we have done in Denmark is that a lot of the researchers actually store the data on USB disk, previously on these small floppy disks. And I think there's a huge problem before we actually get to actually running it. Yes. And that is actually to ensure that we do have the original. Yes. And I think, at least seen from the Danish point of view, and if that is general, I think we have a huge problem about most data being on local hard disks and all these. So I think we need to address this problem before we can actually start to address the other one.
Yes.
And then another problem is that quite often people have used homegrown programs to do, part of it. And we don't have the homegrown programs anymore, or they run on operating systems which don't exist anymore. Mm-hmm. So we still have a lot, but this is a first step.
Sure. I agree with there's this aspect of the input back, because we store things on different devices. I would just only say, because as I said, I work in the corporate world for the last 16 years, and the way to drive it is from the market. If there's a demand, if you create one instance, or if you just create this on the cloud and say some kind of platform that is economically feasible. I'm mentioning cloud because cloud is supposed to lower the achieve the economy of scale lower the cost of computation, and lower cost of storage. And you should hold them on this. This is the promise to the cloud. It has to be realized that way. It has to be cheaper, and it has to be faster. That's what the promise is. So if you put it there, put the software, then there is an incentive then for people who were providing readers. They will see that there is a business. Because then the end users and organizations will see, yes, I actually can process it, therefore let's move on. What do we need? Well, we need to pay a little bit for the input. But that's the only way to move the economic system, the whole ecosystem. Or what I'm basically saying, we want to show first it's possible, this is possible, and then let people ask for the rest. Yeah.
Hi, Izaskun Lacunza from Liver. I have to say that I enjoyed very much your explanation about how knowledge is distilled in a lab. I was a chemist myself, and I really pity anyone that needs to go through my lab books right now. I mean, even myself, I think I wouldn't be able to extract any knowledge anymore. And I think that, well, you mentioned the paper, and at least in my experience, it is in the paper the first time that a researcher actually makes an effort in trying to explain himself or herself to the general public. Yeah. So I think that you've been mentioning several challenges that we need to tackle, and Birte was explaining about, basically researchers storing data in several places, but also, this is more a reflection, probably researchers need to understand that it's not a paper anymore, that they need to start thinking about, from the very beginning, if things are well done, the information would be able to be reusable, not only by others, but even by yourself a couple of years later.
Absolutely.
My question would be, do you think that researchers have had this mental shift already, or are they still very much working in the print, even in the digital?
I do believe that this is an interactive process. The technologies shape us, and then we shape technology. So whatever you show me is going to change my mind. Every moment you show me something is going to happen to my cognitive models, and so it is a deep interaction issue here. And I think whatever we put there, it will change, and practices will change as we provide opportunities for them to change. Yeah. And I'm not sure. It would be very interesting. The question you asked was whether, before we had a digital representation of a paper, whether the digital has changed so much what we've done before by typewriting. I mean, in a way, it would be an interesting question. But I do believe that we will see continuous practice change. And who are we to judge whether it's better or worse? Again, I always stay away from that judgment. I think there will be value extracted in just different ways. Yeah.
And then Birte.
Hi, Trike Zakers, University of Amsterdam. Great presentation, by the way, especially this kind of research which really proves something from the library world we're usually assuming a lot of stuff about researchers. That's actually great. As a side note, the speaker before you actually mentioned Lorcan Dempsey's remark that we're now shifting away from preserving local, that we all have to, as institutions, preserve our chunk of a global ecosystem. Whereas the end of the discussion now and the end of your presentation focused very much on the individual outcomes, individual programs and programs running on computers. I was just wondering your thoughts on that, because those computers, I can't run an XP or 2000 anymore connected to the net. I mean, it would not be safe, or you'd have to, the antivirus programs are out of business and all that. Yes. So basically, we have this chunk of this artifact on itself, but we cannot preserve, at least as it is right now, the whole network. And more, those programs will not even function without the network. Mm-hmm. So there's kind of the same analogy. Yeah. So I think I would like your thoughts on this.
Sure. Yes, absolutely. So in a way, what I skipped here, what I was suggesting, I'll just show you, the strategy really has to be dual. There are two aspects of it. This is basically what we're discussing. Imagine that each of these cells is a computation environment. Because what you rightfully said, I can have a virtual machine and I have an environment where I have everything that was running like XP for this particular laboratory or this particular researcher. And then the researcher moved to, I don't know, Windows 7, for example. So here we got XP and then Windows 7. And if I would like some of the assets from Windows XP to be used in Windows 7, I need to create a bridge. And so what is the bridge? Bridge is nothing else but what you already do. It's migration. And migration, actually, there are two aspects you can do. If it is a homegrown program that particularly researchers was using, so a script that he ran experiments, the only way I can move the script into, say, a new environment and make it run is to what we call port. We need to fix the program to run in a new environment. Okay, so when it comes to software, you have to do the porting. And when you have files, you just look at the target environment and say, what is the best application here that could extract most value out of it? And I move original file into that other file. Basically, that's what I'm doing. And don't ask yourself whether it's the same. It's not the same. It's on purpose not the same, because it's a new application and possibly new format. Okay, so I may be moving WordPerfect to HTML, because in Windows 7 I want to show it on the web. Okay, so in a way the strategy is keep the original environments, and then you have to build the bridges. The bridges is based on porting the software or format migration. The harder problem is, and we all know, what if the original, like browser, required web server? Well, I have to decide at some point what's the boundary of what I am virtualizing. I have to. So if it is very important for, say, Olympic Games in 2000 to preserve their website, what do I do? Well, I need to have the server with the content, and then I will run browser, encapsulate it, and just show that. So in a way, I always have to be clear what is the scaffolding around, and what is it that I keep unchanged. That has to be crystal clear. And because otherwise, we always had this discussion about, oh, yes, but then I have to have a VM and a VM and a VM. Yeah, fine. Just decide what is the nugget that you want unchanged. And then everything else around is going to be scaffolding. And don't even try to say the scaffolding, please, because you will be then virtualizing scaffolding. No, that's not the point. So there is a bigger challenge. If anybody wants to preserve Facebook, okay, what will we do? Okay, so I'm not saying this solves everything. I'm just saying that some of the aspects we might be able to save this way. Yeah.
And there was a question by Berta. And that's then our last question, and then I relieve you for
No problem.
Well, my question is actually very much in line with the last question, because, I mean, what you have talked about is what we normally call emulation,
yes,
in contrast to migration.
Yes.
And when you talk about the ecosystem, I mean, I think now we talked about linked open data and relations. And in order to be part of this ecosystem, linked open data, whatever you call it, you actually need to be able to make an interpretation right now which calls for migration strategy rather than an emulation. I mean, I see the emulation more as a historical artifact. You can go and you can see how it was, you can sort of read, but if it has to be an active part of our research environment,
exactly,
it needs to be migrated.
Exactly. Yes, exactly. So because you are at already what we call exploitation phase. So you have moved things into a safe place, it is running in the original form, and now you're deciding a particular exploitation scenario. And exploitation scenario is because now it's all being indexed, analyzed, you do text mining, and so on. The only thing that we have to be cognizant is that in 10 years from now, the same original may be used in a different exploitation scenario. Or the next exploitation scenario may be based on what we have now, what we have done already as intermediary step. Okay. So what has happened most of the time is that because the software was not accessible so far, nobody even asked to look at the original. So that was not even discussed. So then migration happens and exploitation happens now. And guess what's going to happen with this in 10 years from now? This is going to become obsolete. So the fact that we didn't ask the question the first time doesn't mean that we will not be in a position to have to ask the next time. So I'm just saying, well, while we still remember, Microsoft, for example, is incorporated in 1975. Okay, so most of the people are still alive. Okay, so while we still have intelligence, and IBM is a bit older, Apple has been around. So those are the companies that shaped the digital, most of the digital that you're focusing primarily on. And then, of course, yeah, anyway, my point is, let's do it right now. Let's make sure that all the computation is available. Let's make sure that all the documentation is available. Let's start teaching our kids when they go to, or at least those who study computer science, that they can learn from the past, that the past of what, less than half century for them is as prehistoric as anything else. It's not acceptable. So just put the material into the society so that it's being recognized and can be absorbed, and then start building the knowledge. Your job will be easier too, because you will have then people you can recruit from. Because at the moment, you are the only one dealing with the legacy, and in a very kind of, you're forced to do it in a very shallow way, with file migration, really. And who is helping you with documentation on software? Probably nobody. So in a way, we can put this all back into the mix, and then see what we as a society can do.